So my name is Giovanni Lanzani. I'm a shoe designer at Dataframes Driven. And the talk is Pandas from B-date range to wide long. These are basically the first alphabetical thing that I could find in the Pandas API, and this is the latest one. So that's why the title of the talk. So a bit about myself. Now, first, the slides are a part of a longer public course doing data science with Python that I teach here in Amsterdam. If you like this tutorial, you love the course, and if you don't like this tutorial, you also love the course. So there's really no reason not to go to the course if you're new to Python and data science. A bit about myself. I'm Italian born, 32 years ago, last Tuesday. I moved to the Netherlands 10 years ago before it was cool to move abroad from Italy. So before a financial crisis, it means. I somehow got a master and a philosophical degree in Leiden in theoretical physics here in the Netherlands. I also managed to get 4 kids in the meantime, so the myth about PhD students having a lot of free time is totally true, because I could manage to do both at the same time. And that's also the reason I have a disproportionate amount of caffeine in my blood, so I might talk too fast. Just tell me that. After graduating, I went for 1 year at KPMG, where I was PowerPoint monkey. I was doing software code reviews, basically for big corporations, banks, and government. After that, Dataframes Driven made me an offer I couldn't refuse. And last year, I made my next career step and became shoe designer at Dataframes Driven. And that means that if you get custom design Nike shoes if you come work for us, we're hiring. And the offer that I couldn't refuse didn't involve horses or horses' heads or blood or this sort of stuff, if you're wondering. About the tutorial, so Pandas is probably the most widely known library in the PyData ecosystem, and it was probably on par with NumPy and SciPy. It was initially developed by Wes McKinney while he was working as a quant, and it kind of got fed with what you could do with the existing tools, mostly Excel, I think. And so he basically started his own library with Python. And I heard Wes talking about it, and he said from the beginning, one of the focus of Pandas was about speed. I work in finance, and speed is it's extremely important. And you can really see all the cares that he put into the performance tests that are in Pandas and everything. So once you're using things in Pandas, you can usually expect them to be much faster than what you would write yourself. So we'll see how group by works in Pandas. We saw that Peter in the keynote also had a slide on how to do group by in pure Python. I have nothing against Peter, but I can assure you the Pandas solution is much, much faster because of the way NumPy works, of the way Wes architected the library, and all the other contributors after him. Now he's not anymore the core contributor, but it really left a footprint on the project. The API is really large, so instead of showing everything, I'll try to show the most important stuff. If you already know Pandas, some part of the tutorial might be boring. We do have exercises, though, which you might or may not complete. If you don't do them, then you'll have just to wait a couple of minutes while the others are doing that. And please do ask questions. Otherwise, you'll have an early lunch if we finish too early. So the basic of Pandas. Well, what I usually use, so step back. Who's familiar with the Jupyter/IPython notebook? Yeah, okay, it's a lot of you guys. Very good. So all this talk and the slides are made with the Jupyter notebook. You can use that while we do the tutorial. You don't have to, but I really strongly encourage you to do so. In the notebook, you basically begin like this. At least me, I begin like this. I import NumPy, then I import some matplotlib to make plots, as we will see in the next part of the talk. And then I import pandas. The PyData convention of importing pandas is to import it as PD. So please don't import everything from pandas. So from pandas import star, that's bad. And give it a short name because you'll be using it a lot. We start off with series. Who knows what NumPy arrays are? Okay, so there's a good chunk of you who doesn't. So basically, NumPy arrays are a C-like data structure that you can manipulate in a Python through NumPy. And why is this important? Because it turns out that once you have this, I mean, a lot of work has been done to vectorize operations on these arrays. And by vectorizing operation means sending chunks of this array into the L3, L2, L1 cache of your processor and doing things in parallel in your processor. So that means that operations on these NumPy arrays, you can think about them as Python lists, more or less. It's extremely inaccurate, but just for the sake of the tutorial. And do math operations on them. So Pandas extends the concept of NumPy arrays with series. A series is just a NumPy array, like this, with an index. And you can either pass the index, or Pandas will automatically assign an index to your series. So we can see here that we just create a series with this list. This is a Python list. Pandas, under the hood, attach an index to it and transform the Python list into a NumPy array. And it also tries to guess the best type, which in this case is int64. Can you actually see from the back of the room all the, yes? Okay, great. We can access the values of the series, so we could see that it's just an array of int64, but we could also access the index of the array. So we see here that it's basically, under the hood it's another NumPy array, and it also has the int64 type. So we can specify the index ourselves if we want. So in this case, I'm creating another series with index A, B, C, D. And we can see now that the series has the index that I specified and the same component here. So now you are wondering, why should I put an index on my data structure, on my series? And the answer is that we can access by index. So if we do things like series 2 and then B, I will get a new series with only the B element. If I want to access the value at B, I need to use just a single bracket. So you see the difference here. In the first example, I'm getting back a new series. And the second, I'm just getting back the element, which is 4. And you can also select multiple elements in the series. So here I want a new series, which is just the B and C elements of the previous one. So that's all possible. You can work with series basically in the same way you can work with NumPy arrays. So you could call numpy.mean of the series, and it will reply. You can, series also have built-in methods, like you could call mean to a series and it will give the same answer. Under the hood, it basically does the same thing. So performance-wise, it's exactly equivalent of what you do, or mostly equivalent. You can also do nice things like, I want to square the element of the series, and you could just invoke the **2, and you will get a square series back. And it's all done in this vectorized, very optimized fashion, so that doing this, it's between probably 50 and 150 times faster than the pure Python way, especially with very large series. You can select using a series of Boolean. So if I call series 2 larger than 0, I will get a new series which is composed of Booleans. and each element represents whether series 2 is larger than 0. So we get a true, true, false, false. This effectively is just a new series which contains Boolean, as the D type informs us here. Having that, you can use this series to get a slice of the original series. So here I'm getting back a series where all the elements are larger than 0. And this is the answer. You could also do, use the in operator that will check if A is in series 2. Here, know that the answer is true because A is in the index of series 2. We can also load data from dictionaries. So here there's the literacy percentage dictionary, which is just some made-up data, and these are Dutch provinces, so North Holland, Zuid-Holland, Flevoland, and Groningen. You can see that Flevoland, the one where I live, has the lowest literacy percentage of them all. I heavily contribute to that. And then we can turn that into a series, and you can see that the keys of the dictionary will become the index of the series, while the values will become the values of the series. Again, the D type is assigned automatically, and Pandas try to do the smart thing there. Yeah.
For the keys, are any restriction for what you can put in there?
Yeah, I think I have it in a later slide, but they should be hashable. Well, of course, if there are keys of a dictionary, they should be hashable anyway. But if you're passing an index not through the dictionary, then they should be hashable. So you cannot pass a list as an element of an index of Pandas.
And does it restructure it so it is hashable, or is it just flag and error? For example, in R, if you do that, it changes the thing. So it changes, let's say, the character, so that it is not the same that you put, but it doesn't flag an error. So it just
So the question is, does it flag an error if you pass something which is not hashable?
Or does it transform it to something else?
Or is it transformed? The answer is, the last time I checked, it gives you an exception saying that the item is not hashable. But a good question. If I want, and I'm passing a dict, I could override the index that the dictionary has. So here I'm passing a different index, which is this. And as you can see, the Groningen province falls out of the series, while the Utrecht province is inserted with this sentinel value, which is not a number. And Pandas does that because the Utrecht province was not present in the original data. Once you have this not a number in your series, you can check where they are with the isNow method, and it will tell you that Utrecht has not a number as its value. We can also give the series a name and the index of the series a name. So here we say the name of the series should be literacy, and the name of the index should be province, and this is what we get back. These are, unfortunately, in-place operations, so they change the underlying series, which I not always like because I'm a functional kind of guy. And the index can also be changed on place. So now here we make a copy of the literacy series 2, and then we say the index should be these 4 elements. And then you can see that the index of literacy series 3 change in place. This is potentially very dangerous because you are actually changing how you can access this. And here we have the remark that Rodrigo made: index values must be hashable. Data frame. What's a data frame? So a data frame You can think of it as an Excel file where you have an index on the rows, but also the name of the columns there. So it's basically a bidimensional series with a collection of 2 or more indices, one for the rows and one for the columns. And we'll see later that we can also have multi-indices, so 2 index or 3 index for the rows and 2 or more indices for the columns. Each column here in the data frame has a different value type. Could be a numeric, could be a string, could be a Boolean, and so on. And they can be created in a lot of different ways. We'll see how to create them programmatically, and we'll see towards the end of the tutorial how we can create them by reading a file. So here I have another dictionary, the data dictionary, where the value of each key is a list. And if I just pass it to the data frame constructor, I get back this. Here I'm naming my data frame df. It's kind of the convention, but please don't use it to production, because everybody names things like df, then you'll be overriding your variables. But it's fine for the talk, I think. We can change, if you want, the order of the columns. So we can see here that we had literacy, province here, and now we had province here literacy, because we passed the column order here. We can pass an index as well, if we want, to override this here. And we can also pass new column names that will result in missing data. So if I would add a new column name here that doesn't exist in data, I will get a whole new column with not a numbers. Creating new columns and assigning values is very easy. So we can see here that I'm creating the new nonsense column, which is just the year column divided by the literacy column. Here I'm also presenting the way that you have to access the data which is in a column. So you have 2 options. One of them is using the dot notation that obviously only work if your column name do not have spaces in it, and if your column name is not a built-in method of the data frame. For example, if you name a column sum, you cannot call df.sum to get a value. What you need to do is to say df bracket quote sum closing quote closing bracket. So this is also the way we use to get a column value. So we have here our new df with a nonsense column, which, as the name says, it's nonsense. And what we can do, we can also create a new columns by passing a series. Here something really important happens, in that my series has the index 1, 3, and 4. 1, 3, and 4. And the values are 0, 1, and 2. So Pandas automatically aligns my series with the data frame index. And where data is missing, you get a none. Questions up to here? Yeah, Ben?
Just a quick question on the nans. Is that implemented in such a way where? Do you know if that's implemented in such a way that it's sensible to have a large series that's mostly nans memory-wise? Do you know under the hood? So like if I'm making a sparse matrix, is it disastrous for my memory footprint if I represent it this way? I mean, if you don't know, that's fine.
I don't have the answer. I know that if you're making sparse matrix, of course, the SciPy sparse package is the way to go. I don't know internally. I mean, none is just a sentinel value for Pandas. And Pandas has a lot of machinery to deal with nuns that NumPy doesn't have by default. So for example, if you have, you want the mean of a series that has some nuns in it, Pandas automatically deal with it, while NumPy cannot. I don't know the specific there of the performance penalty if you just have mostly nuns in your data frame. However, if I'm thinking about a use case, it's usually does not happen so much that you want to do operations on a data frame which is full of nonce. You usually first filter them out in some way and then do your operations, because otherwise you're just shooting yourself in the foot not using SciPy sparse package. Oh, yeah, sure.
Yeah, can you tell me what the advantage is of using a series instead of a data frame with one column?
That's a good question. So you have some methods are only available to series and some only to data frames. I don't have now all the methods that that only work on one or the other. I know one of them, at least in the one of the latest versions, was value count. So if you want to do a value count, you need to have a series, and it doesn't work on data frame, and so on. So the API is not perfectly symmetrical between the two. So depending on which method you want to call, you might be better off with a series or with a data frame. The nice thing is that it's very efficient to go from one to the other. If you just use the dot notation on a data frame column, you'll get a series back, and you can very easily pass a series to the data frame constructor to get the data frame. So it really depends on your use case. But I wouldn't know about performance-wise if that. I don't think it matters. It really matters what you're choosing. We can also pass to the data frame constructor a dictionary whose values are dictionaries. In this case, you see that this 0, 1, 2, 3, 4 will become the index. And these values will become the values of the literacy column. So we see here. So this is, Pandas is very smart on figuring out what it should do. As you can see, I could have pure none here, like series aligned 2, and I will get a none here. The same if I would have omitted this guy here. So if this was not here, the result would have not changed. Pandas automatically puts a none there. Reindexing, we can also reindex. So let's say we have this series here, which is just the number from 0 to 9 with an index from for all the even numbers from 0 to 18. And let's say this series actually represents the month of November. So being the month of having the month of November 31 days, we need to reindex, so basically to insert all the missing dates. And we can do that by using the reindex method. So we can see here that I call reindex on series 3, and I say I want every value between 0 and 30. Actually, November has 30 days, so this is wrong. Let's say it's December. And Pandas will automatically put nonce where you don't have values or data in your previous series. This could be problematic for you because, for example, you say, well, actually, if I didn't have a data point, my instrument or my source is assuming that the data for the 1st of December is equal to the data for the 2nd of December is equal to the data of the 1st of December. So reindex as the method argument, and you could say, I want to forward fill the series. So what happens is that if here I should have a none, Pandas will take the value of the previous day. And you can see how it works here. So all the odd index values get the values of the previous one. Up to 18, and from 18 onwards, that was the last point in my original series, everybody gets a 9 value. you also have the backfill if you want the contrary, so the opposite. Yeah.
Question, the index doesn't necessarily have, the index, does it have to be ordered? Because I think your early examples just showed hashable things, so.
Yeah, to use the reindex with this method, I mean, it will, I mean, if you're reindexing, it will take just the previous one, and if it's if it's ordered, you may get what you want. If it's not ordered, you might need to order it, and we'll see how you order an index later to get the result that you want. But you're correct.
Okay.
In principle, to get precisely this result, you need to have things in the correct order.
Okay. Thank you.
Other questions from the audience? Okay. Reindex also works on columns. So you could basically add a new column like this, and you have a row-wise interpolation. So basically, it tries to do the smart things when you're adding new columns. Another very interesting thing is how to drop data, which I do it very often, especially when it does not agree with my model. I work for a bank, I'm just kidding. So here, for example, we can say I want to drop the nonsense column, and if this is a column, I need to explicitly pass axis is 1 to indicate that this should be a column. And you can see that the resulting data frame does not have the nonsense column anymore. But I could also drop a row by specifying the index of the row, in this case 4, and it will drop the Zuid-Holland row, the latest one. Here in this case, I don't have to pass axis is 0 because that's the default. It's good to mention, you could also drop in place by adding the in place is true argument. That will modify the data frame in place and will not return anything. As we already saw, we have a couple of ways to index and filter a data frame. The first one we can, as I said, we can refer to a column using the bracket notation. And if you use the single bracket, we get a series back. If you use the double bracket, we can select multiple columns, and the results will be a data frame. You can see stylistically, Pandas makes a difference between series and data frame by adding this Excel-like cells to data frames and not adding anything to series. So visually, you always know what you're getting back. And Mark is very happy. He gave the visual talk yesterday. He really agrees that these are the really important cues to do your work. We can, as with data frames, we can select data using, as with series, you can select data using Boolean conditions. So for example, I want every rows in the data frame where the nonsense column is larger than 5,000. We get this here. And we can also use fancier indexing with the .ex method. In this case, I'm saying I want the first and the fourth rows, but only for the nonsense and literacy column. And we get this data frame back. And functions, as with series functions, data frames as functions that you could use. You could use NumPy functions on numeric values. So for example, I want to take the square root of the literacy and nonsense column, and we'll get this. Again, these are vectorized operations, so it's very efficient to do, much faster than the pure Python version. And sometimes we want custom function for our data frame. So just to remember everybody, this is the data frame. And we want a custom max function. What this function does is that it collects all the elements of a column if the element is numeric, so it's a number, float, integer, whatever. And if there is anything you want to get the maximum of the sequence, so the maximum of the column, otherwise just return a none. I can use this function custom max. I'm wrapping here into a f to be short. On the f, so for example, I want to say apply f on the f along the rows. So you can see here that I couldn't just apply the max function on the rows because I had string values here. So what I do instead is I wrote my custom max function, which ignores the string, and you get this back. This is applied row-wise. You could also apply it column-wise without specifying the axis, and the results will be this. 10 minutes for the break? Great. I want coffee. Sorting is also possible. So coming back to the question that we had from the front row, we can sort by index with a sort index, or we could sort by row, and we could sort by column. Again, since sorting is done in a computer science sort of way, capital letters are not the same as non-capital letters. So nonsense gets at the end because it's non-capital, it's lowercase. We could sort by values. This actually recently changed in, I think, Pandas 0.17. This method is new, and the old sort method is deprecated. So here, what I do, I'm sorting by literacy, the values of the literacy column, and then I'm sorting by index. So you could see here that 0.5 is as first the second index element and then the fourth index element, because I sorted by this column first and by this column second. The sort values and sort index, they both have the, I think it's called the reverse method to get the sorting reversed, and that you could use. Pandas also has the descriptive statistics, a lot of descriptive statistics functions built in. So for example, well, as we already saw, we could get the sum of a particular column. We could get the sum of every column into the data frame. And please note what happens with province. So Pandas doesn't choke on that. It just, well, does the right thing in Python, because when you sum string in Python, you just concatenate them. And you could also sum using, I mean, on the rows by passing axis equal to 1. And as we can see, non-numeric values are ignored. So province here has been ignored. Then we have the describe method for a data frame. And describe basically takes all the columns, numeric columns, and it prints some descriptive statistics, as you can see on the slide. And if I also want statistics on non-numeric column, I can use the include all keyword, and I will get also some facts about the province column, which is non-numeric, like how many unique provinces we have, the top frequent, and how much time it appears. But we don't get anything for all the other statistics, of course. Questions up to here? No? Okay.
That's it. The output of that is that also a data frame?
Yeah, this is also a data frame.
I have questions about apply. Am I correct that it tries? Yeah, thanks. Am I correct that apply under the hood, it tries to vectorize the computation for this particular column? And also, like, additional question. There are some cases when we need, for example, to apply some function to each row.
Come again?
Apply some function to each row in a data frame. So basically it can be done through apply function, but there are some cases when we need, for example, to do some like database query, for example, for each row in the data frame. And my question is, does Pandas have some implementation under the hood which allows to do such things in parallel? I mean, like for each row, if we do some operation independently for each row, does Pandas have this ability?
So, off the top of my head, I don't know the exact answer. Is that Pandas, they're working really hard to release in the GIL, the Global Interpreter Lock, to be able to do that. So that's one way to do that. The other thing, so in principle, it should be able to do these things in parallel in the future. The other thing that maybe it's also worth mentioning, it's about opening all the connections to the database every time you try to call the function on a row, which could potentially be very expensive. And for that, you have two options. One is to use a class to do that, which I don't like. And the other is to use a coroutine. So basically have the, you know what coroutines are? Yeah, so you basically use a coroutine and you pause the execution and you try to keep the connection open by using that. So basically pausing the execution every time you're finished with a row, but leaving the connection always open. So basically do it in a single transaction, your whole thing. Does that answer your question?
Yeah.
Well, I didn't really answer it, but do you want to ask more?
No,
Okay.
we can discuss.
So let's see the time. Yeah. Yeah, what I was talking about before is value count. Value count is a really invaluable method. It basically counts how many instances of a value you have in a column. This is a series method, so you can, for example, apply to the df province series. The output is another series where the index are the values that you find in the column, and the values are how many times you see that in that particular column. So you can see that you have the index values is this, Flevoland, North Holland, South Holland, which is the same output that you would get if you call the unique element on the df province series. You can see that it's exactly the same. We also have vectorized membership. So if you want to select all the provinces which are either Flevoland or South Holland, you can use the is-in method, which is extremely fast, so much faster than the pure Python operation here. So here what we get is the data frame with filtered out provinces. And now we go to handling missing data. Are there questions up to here? No? Good. That means everybody's sleeping. So handling missing data. So if every data set you ever got did not have missing data, you're probably in the wrong room. So I see one gentleman that is going out. Assuming that all the others did have missing data in their data, let's go on. So when a value is not present, we already showed that you get the non-sentinel, which is just np-nan under the hood. And that value is used as a placeholder, which is easy to detect. So for example, if you want to detect where series align is as null values, we just call is null. And we can see that it returns true if we have a none, and if we return false in all the other cases. Very powerful. So we just said that we have this this non-sentinel in Pandas. Using that non-sentinel, you could do nice things. So for example, you can use the drop NA method to drop all the rows that contains not a number in the series. So if I just take series align that had two not numbers and I call drop NA, I will get this back. If I use the same method on a data frame, it's kind of brutal because it takes out every row that has at least one NA into the data frame, which is, well, as I said, it's kind of brutal. And you could also use different methods like fill NA. In this case, I want to replace every not a number with a 0. You could use whatever value you want. For example, here I use the Nepper number, E. And you also have the flexibility to pass, oh, sorry, it goes into, maybe it's an exercise. Well, anyway, you have the flexibility to pass a dictionary here, where the keys are the name of the columns and the values is the value that should replace for NAs in that column. So you could potentially say, I want to fill the NA in the province column with, I don't know, Limburg. And the value for the series aligned NAs with NPE, and you could do that. So passing a dictionary to fill an A works, and it's very useful.
A few slides back, you had is null instead of is none. Is there any particular reason that null? I think you filtered.
So here we have is null.
Here.
This one.
Why is null where you're filtering for none?
Well, because, so, I don't know, probably a philosophical reason. Basically, when Pandas does not find a value, so a value which is non-existent, it puts an NP none, which is just a sentinel. And then they decided to name the method to kind of, I don't know, to convey that it was non-existent.
Okay, because there is numpy is none.
Yeah, there is none, which is another N-O-N-E. You mean that?
No, is NAN.
Oh, yeah.
I'm just confused.
We will see the difference. It's because you could have now you caught me off guard. But there's a difference because you in how you also treat infinite values. So you have NP none and NP inf, which are two different things. And if I recall correctly, is null and is none, they treat the infinite value differently. I think we'll have an example about that in a few slides.
Okay, thank you.
Yeah, as I said before, I don't know why these two slides are switched. Anyway, as I said before, drop NA can be really brutal sometimes. So you have the how method that basically specify when should you drop a row. And one of the possibilities is to use all. I only want to drop a row if every element is not a number. In this case, nothing gets dropped here. Or you have the threshold thresh keyword that says I want to drop a row if if at least 5 elements in this case are not none. So in this case, here I have 4 elements which are not none. So 2 gets dropped. 0 also has 4 elements which are not none. So also 0 gets dropped from this. Is this clear? It can be, this threshold keyword actually works the opposite of how my brain works. So I always have to look up the documentation. And that's why one of the exercises is to write an helper function so that you can easily drop lines with more than n missing values. So the other way around. So these are very biased exercises because it's tailored to my brain. But it's something that you could definitely do in Pandas. However, because of time, we'll do a quick show of hands. I think it's good if you do the exercises not in the tutorial because otherwise we won't have enough time. Is that all right with you? Yeah, okay, great. Another feature that Pandas has is hierarchical indexing. I'm going to go a bit faster here. Basically, you can have a 2-level index here. As you can see, A, B, C, and D, and 1, 2, 3 are both part of the index. So the index has 2 levels. So here you can just skip all the syntax how this is done. You can look it up in the notebook. I just want you to understand the concept here. So we have two levels here of the index. And you could see that the index indeed is a multi-level index with multiple labels. You could select everything concerning to the B index. What you get back is this series here. And you can see that if I do that, the index of data B is just a simple index. So under the hood, a part of the index is lost, and I just get a simple index here. So this is effectively like a normal series. We can also select data using the inner labels. So for example, I want to select all the 2 of the inner index. I can use the syntax here. The colon is necessary. Again, this is a normal series with a flat index. We can also have hierarchical indexing for columns. And in fact, you will explore that in the exercises that you'll do whenever you want. And now let's go to the data wrangling section. That is one of the most frustrating things, to get the data in the shape that we want. I usually spend probably more than half of my time doing that, and the other half of I spend it in meetings, so I never do anything. So do yourself a favor and pay attention to this chapter. So the first are the merge operations. So let's say we have this data frame, which we already presented, which is pretty simple. And we wanted to merge it with a data frame that contains the population of these provinces. It's very simple. We could call merge without any arguments. And merge is smart, and it compares the columns from one data frame to the columns of the other data frames, and it uses that to do the merge. So just calling this, you can see that Pandas is doing the right thing. So adding the population to the original data frame. If you don't have the same, the slides look like a mess. If you don't have the same column names, you need to explicitly say, I want to merge with the right data frame on the province index, lower P, and on the left data frame, which is df, on the capital province index. You can see that here Pandas does the merge just fine, but the province column is double, so it's present at the beginning and at the end. Here, you could note one thing is that the Zuid-Holland row is out, because by default, merge does inner joins. So who knows the difference between inner, outer joins, left? Okay, well, not everybody. So inner joins, only the common keys are preserved. Left joins, only the keys from df are preserved. The right joins, only the key from df3 are preserved. And the full outer joins, all the keys are preserved, regardless of who has them. Here is how we can change the nature of the join. So for example, here we could do an outer join. So we'd have Zuid-Holland without the population and Utrecht without all the other values, because Zuid-Holland was only in df and Utrecht was only in df4. And now I want to get your attention here. Here we're doing an outer merge with a data frame, df5, that has twice the Flevoland entry. So what Pandas does, it creates 4 entries for Flevoland in the final data set. So df only had 2 Flevoland entries. However, df5 has also 2 Flevoland entries, and so Pandas kind of do a cross join there. So you get 4 entries for Flevoland in your final data set. This is something that you need to know this, because sometimes it happens that you get duplicate data for no particular reason, and you get this sort of behavior. So this is a many-to-many merge. And as you can see, Pandas doesn't complain, it just does that. Yes, Mark?
Yes, how would you remove duplicate rows from your data frame?
Yeah, question is how to remove duplicates. I'm going to check it in the next few slides, so I'll postpone your question. Don't feel abandoned. Again, exercises to reinforce the knowledge you just learned. Another nice thing we could do is that we might want to do is to combine data with overlap. So let's take series A, which is this, and series B, which is this. And we may want to say, I actually want to combine the two series, taking the values from series A if I have something in series A. Otherwise, filling the value from series B if I don't have anything. So for example, the combined series would have 0 in place of F and 2.5 for E because of how I want to do things. So there's the non-Pythonic way to do this, which is probably wrong, but don't blame me, where I say, well, if series A is null, then take series B. Otherwise, if it's not null, take series A, and then attach the series A index to the data frame, to the series, sorry, which is very involved and ugly and error-prone, so please don't use it. The good way to do that is to use combine first method. So basically, Pandas does exactly this behind the scenes for you, and the result is completely the same. So combine first is a very powerful method that you could use in series. Well, again, exercise. Stacking and unstacking. So who knows what the tidy data is? Okay, not many. So let's see, we have this data here, which is the results of a treatment A and treatment B to these patients. So does anybody see a problem with the data structure like this? So what if I want to add the weather? I should add 2 extra columns, right? One for treatment A and one for treatment B. So it's very inefficient to do that. So the Pandas developers know that. And so they had a wide to long method that basically what it does, it takes my patient's data frame, and then it looks for the TRT suffix in the column names. Here. So TRT is a suffix to both column names. And then it says, I'm going to basically take everything that comes as TRT and put it in an index here, so that my data from a wide format became a data in a long format. Now adding things like weather is much more easier because I can just pass a list and I guess it's very nicely formatted data. So if you can, always try to work with a long format data because it's much easier to, I think, reason about stuff. If you want to get back to where we were, which you shouldn't, but you can use the pivot method. Pivot is, well, it's a bit like what we think. It takes the index, which is this, and then the treatment, which is this, and it basically combines that with the index. So what we get back is exactly where we were. So it's a bit complicated to see it at the whiteboard in a boat, I imagine, that is fluctuating, but it's not very difficult after you use it twice. It's good that you know it's there, and it takes a bit of practice, I think, to use properly. Removing duplicates, that was Mark's question. So this is the select distinct in SQL, if you know SQL. Let's say we have this data frame here. Here we don't have duplicates, but what happens if we basically get the same thing back if we call the drop duplicates method. But what happens if we just want to select the literacy and the province? Immediately there we get duplicate entries, so which is this and this. So calling drop duplicates will give us this new data frame here, where all the duplicates are removed. Applying a function to a data frame, this is also extremely... Yeah, oh, sorry.
What if you want to drop the duplicates for those two columns, but retain, say, for example, the first entry of the third column?
Yeah, you would have to do a group by operations, and we'll see them in the end of the talk. So basically, if you're doing a group by, let's say you're doing a group by literacy and province, and then in the group by you can decide what should happen with year. Right? Is that... yeah, so we'll see group bys at the end and how to do this kind of windowing function to like select the lowest year for province literacy and that sort of stuff. Does that answer the question? Yeah. So applying function is done with the apply method. Here I want just to know how long is each column. Unsurprisingly 5 for all of them. I could also say how long is each row. Again, unsurprisingly 3 for all of them. But I could do more complicated things. So for example, I could say if you get a float element, add 2, otherwise do nothing. So here I say df6 apply, if float add 2, and the literacy gets boosted immediately, and years also get shifted. Of course, this is a stupid example, but you can see how this may be useful in your day-to-day practice. Again, exercises for you. And here's the note. The apply function tries to work on an aggregate basis. So it tries to do the operations in one pass. So it tries to do the operation in the NumPy way. So basically, when you're adding 2 to this year column, you're basically passing the whole column to the CPU at the same time, and the CPU is taking care of adding 2 very efficiently. However, sometimes you can't always do that, and apply may fail in that case. So you can use the apply map function that applies a function cell by cell to put it in the Excel nomenclature. So cell by cell or element by element, the function will be applied if you use apply map.
So I've been trying this quite a lot with to do like a case when type of structure that I would have done in SQL.
Yeah.
And I tried to write it first as a function that I passed to the apply thing. But the problem was that it came out really slow. And then I started using MP where instead, which was like an enormous improvement.
Yeah, you could, well, we'll see an example there, but what you can do, of course, is to pre-select your data with like df brackets, df series larger than something, and then apply this function, and then you basically concatenate that with the function that you applied on the other region of the data frame. But using where, it's also a very good way, and probably under the hood is happening the same thing. But of course, Pandas takes care of stitching things back together for you. So I mean, it's both good ways to go about it.
Thanks. So, and I also heard that, well, continuing the same topic mostly, I heard that there is some kind of decorator, like NumPy UDF or something. You can apply it to a function, and NumPy tries to convert it to a vectorized version, which will be slightly faster.
And p.vectorize. You mean?
Yeah.
Yeah. So if you have a function like, well, I wouldn't think of anything now. Well, a function that is not vectorized by default, and so it works on element by element. You can call and p.vectorize on that, and NumPy's try to make a vectorizable version of that function, which will be faster than the non-vectorizable version, but it will be slower than the built-in vectorize operation that NumPy has. So, for example, if you want to bake your own version of sum in a non-vectorizable way, and then you vectorize it with the NumPy vectorize function, it will be faster than your original version, but slower than the pure NumPy version.
Yeah, thanks.
Mark?
Yes. In the example you showed, the function was being applied to each column. Now, in most practical circumstances, what I want to do is that I want to combine multiple columns together and be referencing them by name and have this applied sort of row-wise into a new row or into an existing row. What is sort of the best idiom to use?
Yeah, so if I'm not mistaken, and here you could now let me think. I think you can reference by square bracket, like say if you have like, or by I think by position. So if you're passing a function that needs to take the element of the first element of the first column and the third column, you could say x0, and then we would take that element, and x3, and it would take the fourth column, and you could combine them inside the apply. So here you could say L0, and it will take literacy, and then L2, and it would take year, and you could do stuff together. And I'm pretty sure you can do it by position, and I'm not sure if you could also do it by name. So just saying X literacy. That I have to check it out. Oh, so replacing values. So sometimes we wish to replace values from a data frame. So for example, in this case, we clearly have some outliers here, the 999 values. And we want to basically replace them with something else. One of the way we could do is to just use the replace value here. So we say every time you see a 999, I want to replace it with the median of the column. So for column 0, 999 will become the median of that column. For column 1, and so on. So it's very powerful. Yeah, this one actually has an first exercise an error. Well, not an inconsistency, because here I'm using the median, but I was doing the example here where I was using the mean, so the outlier would really influence what was replaced. So one of the exercises is to write a function that computes the mean of the column, ignoring values larger than a particular x, and plugs it back into the original data frame. It's also something that you can do. Another option is, let's say we have also some outliers here, but we know that once they're above a certain threshold, we want to put for example, the minimum and maximum values that the instrument can register. So let's say, for example, that where I have a -10, I should really have a -1. And once I have a 10, I should really have a 1. So like the instrument is giving wrong values there. So to do that with this data frame, again, ignore this. It's just to create it. I can use this very nice syntax, and I say, select all the cells where the absolute value is larger than 1, and put in the sign of that particular cell. So you can see here that where I had a 10, I get a 1, and where I got a -10, I get a -1. So you're basically cutting your data frame. Questions up to here? No? Okay. Another nice thing that Panda has is that we can do a binary decomposition of categorical variables. Because sometimes you need to use some algorithms that needs, how it's called? Well, they don't work with categorical variables, they work with variables that have mean 0 and a variance 1. So you want to fix that. So let's take the sector data frame. I'll show how it looks like. Basically, the sector data frame has some size of companies per sector and some revenue there. And what I want to do is to take these industries, which are 4, automotive, energy, infrastructure, and transportation, and basically decompose that into 0, 1 data frame. So the 6th company is an energy company. So I put a 1 at energy and 0 otherwise. The 15th company is an infrastructure company, so I put 1 here and 0 otherwise, and so on. Once I've done that, it's very easy to get to a data frame that has all the automotive column, the mean of the automotive column to 0 and the standard deviation to 1 by using the scale function in the sklearn pre-processing. So you can see, 10 minutes? Great. You can see here that I'm scaling my binary industries. And if I call the describe method on the scale binary industries, I get that the automotive column has indeed a mean of 0, practically 0, and a standard deviation of practically 1. And the same with all 4 columns. At this point, I can do a regression that assumes that this column have these properties here. So what I can do, I can join back the scale binary industries into client, and I will get the 4 new columns here. Again, it is very easy and fast to do with Pandas and scikit-learn. So plotting in Pandas, this is slightly less painful than matplotlib. Who likes matplotlib? Yeah, nobody? Oh, no, just ignore you and you. But nobody practically likes matplotlib. No, I'm just kidding. Anyway, Pandas has this plot method on data frames and also series, which allows you to plot things very easily. So for example, here I want to plot, we already saw that, here's my cursor. Yeah. I want to plot the size as the X, the revenue as the Y in a scatter plot, and Panda takes care of that for me. You may want to do, you could also plot a series. So this becomes the index, and this is the value. If you pass a series which has a datetime index, Pandas does the right thing for you, and it makes it very nice. So this is a very nice index. And if you have multiple columns, Pandas will plot each column in a different color, and will put a nice legend here for you, with very little effort on my part. So here you can see that to plot this guy here, I just call plot. The rest is all the defaults of the library. Yes, Ben?
Is the legend getting placed in a sensible place automatically, or did it just happen to go in the upper left?
Oh, that's a very good question.
Because matplotlib handles that by default usually, so it uses, there's like, I think it's best is the setting for legend placement.
Yeah, so
And I'm just wondering if that's going on here.
on the background, Pandas is using matplotlib. So my guess is that it's keeping the default that matplotlib has, but you can also pass the legend keyword arguments there, and basically Pandas pass it on to the matplotlib backend, and it will do the right thing. So under the hood, plotting in Pandas is just plotting in matplotlib with a lot of defaults to handle this sort of data. Bar plots are also possible. Again, I just have to pass plot, and then with the right kind, I can do horizontal bar plots, passing an H at the end, I could do stacked plots if I want. They look very nice. Again, very little things I have to write after I get my data in place. So this is getting my data in place, and plotting is just, I don't know, 20 characters, 30 max. If you use matplotlib, you know that it usually takes a bit more writing to get it right. Histograms are also possible. So you just pass the hist keyword, method, with the bins keyword, and Pandas does the binning for you and does the plotting for you. If you don't pass the bins keyword, it tries to optimize the number of bins depending on the data you have, but it's not always what we want, so you can override it like this. Pandas also offers KDE distribution, which is kernel density estimate distribution, similar to the Seaborn library. Again, you can do it in very little lines of code. So in the first line, we plot the KDE, and in the second line, we plot the histogram. Note, I know that this data is different than this data because I'm calling random twice. So it's not an error. It's by design. Again, there are many more things you could do with Pandas and the plotting things in Pandas. And a lot of them is very similar to what Seaborn offers. Deciding what you want to use, it's up about you. I mean, I usually just use Pandas for conveniency, and if I need to do more complicated stuff, I try to use Seaborn. Seaborn is also working really hard to integrate nicely with Pandas, so it has a concept of columns and that sort of stuff. So it's very good. Data aggregation and grouping. Who knows the group by in SQL? Oh, okay, almost everybody. I see. So basically, in the group by, we want to select a particular category from our data and then apply a function to that category. The group by machinery in Pandas is where Pandas really shines. So the things that Pandas can do here are much more terse, concise, and faster than what SQL can do. And we show a bit. So this is the client data frame. We can see that we can group by sector and then take the median of the revenue. And this is what we get. I'm going to quickly skip this slide. We can also take the mean, for example, of 2 columns. And again, Pandas very quickly gives us the answer. If we want, we can very quickly convert the wide data into long data by using stack. So here basically I'm writing this and then stack at the end, and you get this out. You have other methods built in like count, min, max, median, and so on. And something that you don't have in SQL is that you could actually just get a grouped object here and then do something with it. And you can see that every grouped object contains the name of the group and then the data frame, which is a sub-selection of what you had in that group. You could also group in a different way. So let's say this is the data that we have, and we want to do a grouping with all the even and odd members of the index. So we have a question there.
I'm just wondering if you also have something like a having clause, like in SQL. You know having? If you combine it, it's
where you are doing the
where with group by.
Yeah, I cannot think about it now. My brain begins to be fried, but I can think it in the break. So if you come back, I think you can do something similar, but it's just I need to focus a bit to reply to that.
Thanks.
I have always excuse for the difficult questions. So here, I'm having this dictionary that says that the 0 is even, 1 is odd, and so on. And I can pass this dictionary to the group by. and then take the mean. And what Pandas will do, will intelligently say, this is the mean for all the A even. And this is the mean for all the A odd. It's very powerful. Alternatively, if you don't have the dictionary, you can pass a function to the group by and saying, I want to group by again by even and odd, and you get the same result. Also very powerful. So you pass a function, this function gets applied to the index, and the result of the function determines the grouping keys here. If you have a multi-index, you can also group by different level of the index. So again, ignore this code here and concentrate here. We have a multi-index on the columns by province and by these numbers here. And I could say I want to get the mean of per province along the along the row. So you get here 6, which is the mean of 6, 7, and 5. And you get here 6 again, which is the mean of 9, 1, and 1. So again, the syntax is you pass the level, and then you pass the axis. You can define your own aggregate function. So here, for example, you want the distance between the maximum and the minimum. And you can pass this function to the ag keyword, and you will get the difference between the maximum and the minimum on revenue and size. Again, if this is supposed to be a NumPy array, so these are vectorized operations. Very quick. Other methods work very good for the grouped object. So again, we saw that the group object is just an object containing the various group, and you could just call describe on them, and it will give you 4 data frames, and they will be stitched together. So this is like calling describe on each of the sectors. And let me see the time. I can probably close by showing the transform keyword and what it does. So what a transform keyword does, it does like the aggregate function, but when what it does is that it sticks back the average into the original data frame. So you can see that this is the original data frame, but Pandas added a column with the average of the sector. So this is the average of the sector. So every time you get an energy company, you get the same number here. This is something that you can achieve with window function in CQ, and it is very powerful. And probably last slide because of time. Oh, you could demean stuff as well. So it's very powerful. The last slide is this. That comes back to the question from Eneko. And I want to get the largest company by size and sector. So in order to do that, I use the group by apply. The group by apply basically takes each grouped data frame. It applies the top end function. The top end function takes a data frame. It sorts by a particular column, in this case the size, and then in descending order, and it takes the top 2. So you can see here that I did the group by, the apply. The result is the original data frame, but with the automotive sector, just the 2 largest companies by size. And the energy sector with the 2 largest company by size, and so on. And Pandas stick that back together automatically for you. And I have, I think, probably about 25 slides more. You can do it, with exercises, so I guess you'll have to do it at home or whatever. Question there from Eneko again?
Hello. So I was wondering, maybe you could clarify some of the similarities and differences in performance and flexibility when you compare Pandas to R packages such as dplyr and data table?
A very biased answer here. As I said before, Wes really, from the very beginning of Pandas, it put a lot of effort into making it fast. And it really shows that sometimes it basically researched state-of-the-art algorithm, for example, to do the value counts, I think, which is much, I mean, at least it used to be much faster in Pandas than in R. And I don't want to say that our community is catching up on this, but it's not always as fast, I would say, purely because from the beginning, the focus was we need to make it fast, and we have performance tests. So if you're adding a new feature into Pandas, it needs to have a certain level of performance. So everything is C++ or C under the hood. So everything can get to the same speed. But I mean, I like Pandas more. It's a short question.
So thank you, Giovanni. No more questions? Thank you.